Hello and welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you a data structure called indices that is used for storage strategies in DBMS. So let's begin. Now consider this relation that you would see if you wrote a simple query saying select star from instructors. So it's a very simple relation. And if you write select star from instructors, then this is what you get. You will be getting simply the names of all the instructors in the form of a table with rows and columns. And that's very easy to see and very easy to understand. But when this table is actually stored in the secondary memory, it is not at all stored in this form, in the form of rows and columns. It is, however, stored in the form of blocks in the secondary memory. And then these blocks have to be fetched one by one into the main memory in order to make it work. So in order to do that, you require a sequential file for instructor records like this, where the first row of instructor points to the second row of instructor by storing the address of the second row, because it's not necessary that both rows are stored consecutively or in consecutive blocks. It could be in different blocks. And so we can store the address of the next row with the first row. So this is the simplest way of doing it. If somebody types select star from instructor, then they will simply get this entire table and they will get everything one by one. Because first, obviously the first row is fetched, and when the first row is fetched, then the address of the next row can be read. And when the next row is read, after that, the second row can be the third row can be obtained by seeing the address on the second row. So that's how you can do it. It's the simplest way of doing this type of an access from the secondary memory to main memory. But this is fine as long as the queries are limited to select star from instructor. What happens when the queries become all about constraints, like select star from instructor where department equal to computer science, or where salary greater than some salary? So in this case, you would have to read the entire table, and then you would have to decide which rows to fetch and which rows to leave out there. But you would still need to read the entire table. You would need to go to each and every block, each and every address mentioned in the different rows. And this performance becomes even worse if I try to search for a particular instructor by giving a particular ID. So if I'm just doing select star from instructors where ID equal to any IDs given from here, then I'm only looking for one instructor. And at this time, it's even more difficult because when it tries to search for a particular instructor, it needs to go through the addresses of all the records and then match the given ID with the IDs in the table. And if it matches, then return the result. And it's also possible that the ID given does not match at all. Then in that case, you will not be getting anything as a response, and yet you would have to go through an entire table. And of course, in reality, tables are much bigger than what I'm showing you here. So that's why we use indices in DBMS, which make our access to database a lot faster when it comes to reading it from the secondary memory and bringing it to the main memory. And there are several types of indices. We're going to cover all of them. The first type of an index is a primary index or clustering index. And second, we have a secondary index or a non-clustering index. The third type of index is a sparse index. The fourth type of index is a dense index. The fifth type of index is a multi-level index. Now, in this video, I'm going to talk about the first 4 indices. And for the 5th indice, I have 2 more videos which you can watch and understand what a multi-level index is. But the first 4 I'm going to cover in this one. So let's begin with the primary or clustering index. So primary or clustering index is where the search key is the primary key of the table. So if this is my table, and I can already tell from the table that the ID of the instructor is the primary key. So if the search key in the sense the way the index is built, if that index is built on ID, and that means with the ID, the address of that row is stored somewhere. So it's very simple. Just the IDs are stored in the index, and with the IDs, the address of the entire row in the secondary memory is stored. So that's a simple primary index where because we are using the primary key of the instructor, we are calling it a primary index. For example, like I said earlier, that ID is the primary key, so that could be your primary index or clustering index. The second type of index we have is a secondary index. So a secondary index is an index whose search key is not the primary key of the table. For example, if we take this once again instructor relation, then an index that is built on the salary column would be an index that is a secondary index or non-clustering index. Now, in this case, you can see how it is built on salary. There are several salaries given, and from there are also some salaries that are repeating. So when salaries are repeating, then only once the record is stored in the index, and then after that, the record points to 2 different rows which contain the same salary. So that's how the index is created. And so if I want to search for people with salaries greater than some salary, then it's very easy because this index is already sorted. So when index is sorted, it becomes very easy to search for a certain salary. And I just have to check my index and find out which index, which up to which salary I need to check and read from the table. I don't have to read the entire table. The next type of index is a sparse index. Here, an index entry appears only for some of the search key values, not all. It can be used only if the relation is stored in a sorted order of the search key. So a sparse index looks something like this. And you can see what happens in this. There are several rows available. And out of those rows, I'm building an index on ID because as mentioned here in the rules of a sparse index, we can only create a sparse index if the relation is stored in sorted order of the search key. And you can see that the relation is stored in sorted order of ID. The names are not sorted, the departments are not sorted, the salaries are not sorted, but IDs are sorted in themselves. And that's why I can create a sparse index on IDs. So what I have done is I have picked certain values. For example, I picked the first value to be in the index, then somewhere in the middle, another value, and then skip some more indices and one more, skip some more IDs and one more ID selected. So how this helps is if I'm looking for a particular ID, for example, I'm looking for say 12121, then I just need to check the index. And although the first entry points to only the first row, I can compare my ID with the first entry, and I can know that my ID is greater than the first entry. And so I'll compare it with the second entry, and 1 to 1 to 1 is less than that. And so I will go back to the first entry, check its address, and I will know that my index, my ID is going to be present in this range, in this much area. If it is not present there, then that means that ID does not exist. And I can conclude that without looking at the rest of the table. I just need to look at the first maybe 4 or 5 records to realize that this type of ID is not present. So that's how sparse index helps, and it is also sparse, so it occupies less space since we are not creating an entry for each and every row. Now the next type of index we have is a dense index. So a dense index is where the index entry appears for every search key value in the file. So an example of that would be this one, where I have created an index on the department names. Notice that indices are always in the sorted order, but in the table itself may not have those columns in sorted order. So I have not actually changed the order of the table. I have changed the way I have stored the index, the way in which I have stored addresses in the table. So the first record is biology, which points to the row containing biology. That does not mean that that row is the first row now. This is just pointing, and because B comes first, that is why it is there on the top. Just otherwise, you'd have to make a lot of arrows crossing each other. So this is biology, and then computer science. You can see it points to the first record of computer science, and then the rest of the computer science can just follow. If you find the first record containing computer science, you can find the rest by checking the address. And that way, whatever department names are having are appearing more than once, those are stored in the index only once, and they point only to the first record of that department name, and from there you can fetch the rest. So this is where each and every entry is made. Whatever departments you see in the table are all present in the index. So it's a dense index. So we have seen what a primary index is, which contains, oh, and one more thing, dense indices can be made on any type of column, regardless of whether they are sorted or they are primary key or not. So primary index or clustering index is an index that can be created only on the columns that are primary keys in the table. And secondary indices or non-clustering indices can be created on any type of column. And sparse indices can be created when you have a column for which you don't want to make all the entries. You want to make only some entries because maybe your table size is too large. So you can create a sparse index where you don't include all the rows in your index, where you don't include pointers or addresses to all the rows in your index. And then you can have a dense index where you include each and every entry from your table in your index. So those are the 4 variations of indices, and they make our reading of the data from the database considerably faster. You can make it even faster by using multi-level indices, which I'm going to explain to you in the next video. So I'll see you in the next video. Thank you for watching.